Hi guys, in this video we're going to just review our unit over transformations. So some things we talked about in these transformations were rotations, reflections, translations. What I have written in the note sections are just those different coordinate rules. Up to you if that's something you want to put on your note card that you think would be helpful. I'm just going to go through a couple examples here, you guys. First, determine the coordinates of segment AB after translation along the vector 5, -4, given the coordinates A, 7, -2, and B, 3, 2. Okay, so remember this vector, another way to think about this is one notation. This is the same as this component notation. So what this means is I moved right 5, so the first number is an X, it's going to be left or right. Kind of this note up here. If, actually I'm going to put that up here too. Okay, so this is vector notation. This would be component notation. So A is left or right. It's right if it's positive, left if it's negative. B is up or down. It's up if it's positive, down if it's negative. So this is saying we need all my X coordinates to add 5, all my B coordinates to subtract 3. So I'm going to add 5 to 7. So A prime is going to be at 12. And we're going to subtract 4 from the Y. So -2 minus 4 gives us -6. B prime, we're going to do the same thing. So I'm adding 5 to the X coordinate. So 3 plus 5 is 8. And I'm subtracting 4 from the Y coordinate. 2 minus 4 is -2. So there are my new coordinates. Notice the pre-image does not have the tick mark. Image has the tick marks to show that is the new points. Okay, this next one. Below is a reflection over the x-axis is shown. What would the coordinates be of the image if PQR had been reflected over y equals x? How about reflected over x equals 1? Okay, so here's my original triangle PQR. If it's reflected over the line y equals x, okay, so remember we have a rule for that. If I reflect over the line y equals x, all my ordered pairs just switch places, okay? So if I go back to this example here, we have... I'm going to put my original coordinates. Okay, so P has the coordinates 2, 5. Q has the coordinates 6, 2. And R has the coordinates 2, 2. Okay, so the reflection over y equals x. All right, let me put this X here. Okay, so if I were to reflect over y equals x, that line, remember that's kind of this 45-degree angle line, slope of 1 goes through 0, 0. So if I do that, my P prime would switch places. So it'd now be at 5, 2. Q prime would be at 2, 6. And R prime would still be at 2, 2. Okay, so that's where my new coordinates would. Really easy with the rule. You also can see if I plotted these points, it'd be perfectly mirrored over that y equals x line. Okay, so now if I wanted to, I'm going to go down here. So if I wanted these coordinates to be over y equals x, or I'm sorry, x equals 1 is the other one. Okay, this one is not one we have a rule for, but we know what the line x equals 1 looks like. It's a vertical line through 1. Okay, so that's my line x equals 1. So all I have to do is flip these points over this line. So R is 1 unit away, so it's going to be 1 unit away when I flip it as well. So there would be my R prime. That's at, so R prime, instead of at 2, 2, it's at 0, 2, if I do this transformation. Kind of going out of order here, sorry. P, if I were to do this, so again, it's 1 away. When I reflect it over that line, it's going to be here. So it's at 0, 5. And Q, if I also flip it, so right now it's 5 away. It's got to be 5 away here. So there's 1, 2, 3, 4, 5. So there is my Q prime. It should still look the same size and shape. It is just reflected over that line x equals 1. So this point is now at -4, 2. Okay, so if we don't have a coordinate rule for it, you can use the graph. If we do have a coordinate rule for it, you can just apply that to find the new coordinates. And that's all for the transformations examples. Thanks for watching.